those huge trucks for quarry mines and stuff like that, and so that they don't have to do any obstacle avoidance. Oh, there's a big, huge boulder in front of us. Every other vehicle has to go around it, figure out how to get around it and whatnot. The big trucks will go like, oh, I'll just roll over it. That's how they, that's basically a shortcut. Stanford won that competition with a Volkswagen Touareg. Basically a mechanically unmodified Touareg, but with a control system instead of the usual human interface to drive the car. And that's impressive. The Touareg is not even a true SUV from the sense of having fully interlinked four-wheel drive system. It's only a half-baked all-wheel drive system. So look it up. It's interesting. How the technology leapfrogged very, very rapidly in these competitions. The DoD basically got billions and billions of dollars worth of work done for millions only. The prize money for each competition is only like up to $5 or $10 million, which is a drop in the bucket in terms of the DoD budget.
The other way to look at it is that the government was wasting.
Well, but it's at least a good thing that they realized that they were wasting money with these, defense contractors who promised everything but could not deliver anything. Exactly. So finally, someone realized, oh, we can just spend millions of dollars and get these schools to butt head with each other, and then technologists go, it's done. It's even in the street view vehicles now, which is amazing. Now, that's not an entire digression from this class. Why do you think it is not a complete digression from this class?
Because algorithms control the cars.
The limitation has always been software. Okay? In terms of hardware, what do you have as hardware when you drive a car?
Eyeballs.
Eyeballs, exactly. And how many of those do you have? A maximum of 2, right? Right? Now, if you think about it, how much hardware you have and how much hardware one of these autonomous vehicle has, you have a lot less. Okay, your eyeballs is not nearly as precise as the lidars. The lidars are basically 3D radars. Okay, they don't just give you an imagery. Okay, they give you the exact distance from the lidar to a point of reflecting the light. And this is all 3D. They can give you a 3D profile of your surrounding at all times during when the thing is powered up. You don't nearly get as much information from your eyes. You can kind of guesstimate, from here to the door is approximately 15 feet. Okay, but that's like give and take maybe 3 or 4 feet. It's not nearly as precise as a lidar. The lidar will tell you exactly, everything all the way down to millimeters. Okay. So we start with a lot less information than these vehicles do. So why do we drive still more capably than most of these vehicles, not counting the top-notch ones?
We can make decisions based on a lot more things that.
But that's not the hardware anymore. Okay, it is not hardware anymore, which means in theory, they should be able to come up with these vehicles with just 2 video cameras, okay, to give them, the same thing as we do. They can have sensors like accelerometers, which we do too. Okay, we can actually detect, orientation change and stuff like that. And that should be all they should be needing for these autonomous vehicles. And yet they have all these specialized devices, and they can just approximate or get to the same point as we are at this point in terms of driving. So that tells you what? There's a lot of room to improve in terms of software. Okay? And I think robotics will become a much more important area by the time you guys graduate. It will become more and more important. That and also computer security, those are the 2 main fields that will basically see more attention and more growth in the near future. Okay, any other questions? Yep.
Whatever happened to that power-assisted robot that did the all-terrain, carries several tons across all terrain. It was a virtual walking machine where the guy stood inside of it and carried a payload on his back.
Are you talking about exoskeleton stuff?
Something like that.
Yeah, they still have the research on those items, but I'm not sure how far
I
they
haven't
go.
heard anything about it for years.
They're not as interesting. They're not as the military is not as interested in exoskeleton stuff because you still need a person inside that thing to drive it around. They're more interested in fully autonomous vehicles to deliver people, items, medical supplies, and whatnot. Yep.
No, back to the microcontroller, the flash memory. How is the flash memory works on magnetics like a hard drive? Or is it like
No, it is okay. It works off a concept kind of like an electron well. Okay, so kind of imagine that you have a well or a kind of like a storage system. You can either fill it up with electrons or you can deplete it from with electrons, so it doesn't have any electrons. So eventually it has leaks. So that's why flash memory cards can only retain the data for so long unless you keep rewriting to the sector again and again. It works basically off of the same principle. Okay, so that's a bit of digression, but I think it's good, because we actually do have the time in this class. We are kind of ahead of the other classes. And we are back to the 1021 files. Let me just take a quick look at where we were before. I'm pretty sure we started talking about parameters already. We talked about by-value parameters in this class. We have not talked about by-reference parameters yet. So are there any questions about by-value parameters, which is something that we did talk about last time? No questions? Okay. It is important to read the notes. Okay, that is actually important. This is the first, this is one of the programs where we use a local variable, but without using a by-value parameter. Okay, so what we'll do next is to talk about why we need by-reference parameters, which is another type of parameter. And we'll start that with the swap logic. Do you guys still remember how to swap the values of two variables?
No, temporary variable.
You need a temporary one. You need 3 assignment statements to kind of toss things around a little bit. Okay, so we'll get started with that one first. Okay. So the logic to do that, I'm going to skip a few lines because I need those lines back a little bit later. If you want to swap the content of x and y, how do you do it? You need a temporary variable t. So you say, okay, we'll remember the value of x in t initially. And it's being a little bit sleepy. Come on. Work. Just to show you it's not me being slow. Yay, all right. So t will remember the old value of x initially. X will then get the value of y. And y will get the old value of x. And therefore we swap the values of t, which is stored in t. And that completes the swap sequence. So as you can imagine, swapping the values between two variables is a pretty useful type of operation. We might want to do it from different places of the same program. As a result, it makes sense to turn it into a subroutine because that's exactly why subroutines are useful. They capture a piece of code, give it a name, then you can reuse that piece of code from anywhere within your program. So we'll turn this into a subroutine. So we'll say define sub, swap, and then we have n define sub, which is just the indicator of the beginning and the end of a subroutine, and use the right indentation. I intentionally left 3 spaces here because I have not told you what x, y, and t are. Should we use global variables? Avoid them if possible. Exactly, because global variables are evil. Okay? They appear to be cute, but they are actually very evil. So what we want to do is to figure out how do we do it like this. Okay, we have currently we have two mechanisms. We have local variables and we have by-value parameters, right? Okay, so let's start with just analyze. Let's go ahead and analyze this code here, and then we can say at least which one has to be a local variable and which one has to be a parameter of sorts. Okay, let's look at t first. What should t be? Why do you think t is a local variable? Yep, and you can also look at the first axis of t. What do we do to t? The very first thing we do to t is to do what?
Override.
Is to overwrite its current value. Okay. Now, why would that jive with the way we use local variables? Because local variables start with what? What is the initial value of a local variable? Unknown, unspecified. Okay? So the proper thing to do to a local variable is to overwrite it with a known value. And that's exactly what we are doing. So this is a big clue that t really should be a local variable t. Okay, fine. So that's local variable. We will have a new topic later on, just to talk about how do we know which name is a global variable, which one is a local variable, which one is a by-value parameter, and which one is a by-reference parameter, which we have not talked about yet. Okay, what about x and y? Should x and y be local too? Why not?
Because you're carrying that value from another area in the program.
That should be in trace, right? I mean, someone has to be giving me, oh, this is the variable x, this is the variable y. I want you to exchange the values of those two, variables, and expect it to be known. But at this point, since we have not talked about by reference parameters, we can only guess that okay, maybe it's a by-val. Maybe both of these are by-val parameters, and some of you can immediately identify this is not the right thing to do, but we'll just do it this way first, just to see why it is not right. Okay. Now, because x, y, and t are all local to swap, the main subroutine will also need its own critical variables. I would use I and j instead, so that these names are completely different from the names of the parameters. So I would say I starts with the value of 5, j starts with the value of, say, 14, and then we... Oh, it's hard to see? K. Okay. So then we say invoke, swap, and then we have to specify, I, the expression I is used to specify the parameter x, and the expression k will be used to specify the parameter y. Every time you have by-value parameters, the invoke statement has to specify, oh, this parameter has to start with this value, this parameter has to start with that value. Is that okay so far? Does everybody understand why I reverse the direction of the arrow? It indicates the flow of information. I is what I'm evaluating when I'm using the invoke statement. That value is going into x, which is the name of the parameter in the subroutine that I'm dealing with. Okay, so this should work, and it does to a certain extent, but it does not do everything that we want it to do. So we'll go ahead and save it first, give it a name before I forget. So I call this bad swap because it doesn't really do what it is. It doesn't do everything it is supposed to do. It does do only a portion of what it is expected to do.
Oh, I see a problem already. You're not returning the values
Exactly.
back to the program.
Yep. But let's go ahead and trace it anyway, just to see why we have a problem with this. Okay. We don't need a column for comments because there are no conditional statements here. There are no loops either.